It's time to start a new repair video series, and the subject for this series will be this machine. If you don't recognise it, it's a Toshiba TOSCAL BC1411. It is of course a calculator. It's a nixi tube calculator, and I think these were designed back around 1964. The first release was around 1965. I don't know when this one was built. We'll have a look inside and try and figure that out later. This unit I believe is faulty. I haven't tried switching it on yet. I didn't buy this. This is in for repair, although I suspect this may well end up as part of my collection. These are particularly interesting machines. I've repaired about 3 previously, and they are interesting not because of what they do, but because of the way that they do it. And as ever, if you've watched my channel for any length of time, you'll know that I'm a big fan of discrete designs. So there is no central processor in this. There isn't really a processor of any recognizable sort at all, so there's no microcode unit in this as you would get in the HP units. This unit's built more around a state machine and a series of counters, and so each of the functions basically starts a particular counter that runs the machine through a particular series in the state machine, and it uses that to perform the various functions. What makes this machine particularly interesting is that it uses a very early form of dynamic memory. We'll look at that in more detail as we go through the repair, and that's if it needs repair. I haven't had much luck recently with repairs. Things just seem to work when I switch them on, which is a bit of a pain when you're trying to make a repair series. But as I say, the memory is dynamic memory, and if you want to really learn about electronics, a machine like this is an excellent way to do that, because of the way that it handles its memory and the way that it creates the memory system. Now unfortunately this unit's had a very rough life by the look of it. It's got several dents, the paintwork is very badly scuffed up. I may consider refinishing this. It's not something I do very often. But as I say, if this ends up in my collection, I may well go all the way in restoring this and try and get it back up to its former glory. But we'll start off by powering this up. Now it's a big heavy thing, weighs about 15 kilos. I would not normally start by powering it up. As you know, I normally take them apart before I try applying power, but I do know that the previous owner did power this up fairly recently. And he said it will work in addition, but the other functions don't work. So we'll have a quick look. Quite often you can get some idea with these as to where the fault might lie by just seeing which parts of it work and which don't. So as I say, big heavy thing. Haven't looked inside yet, so I don't know exactly what the internal state will be. The mains cable needs replacing. It's badly twisted and showing signs that it might be internally damaged. But we'll get this powered up, see what it does. So we'll turn on the bench supply. I've got it set to around 230 volts. We'll power this up. It's gone through its normal restart. If you see any flickering, that's just because of the multiplex nature of the display. When you first power these up, they go through a reset sequence. They're quite clever machines, and it goes through and it clears the internal memory. There's a buffer used for the keyboard, so as you enter digits, you enter data into a buffer, and you also have a buffer for the display, and you can transfer that data around depending on which keys you press. We can see that it's gone through that first step, so we know that the state machine and the clock etc. are running, otherwise you'll just get garbage showing on the display. This is all hard coded, so there's no ROM or anything of that nature in this, and one of the issues is it does have, or these do have bugs, and the previous ones I've worked on, you can create issues where you'll get more than one digit on a particular nixi tube showing up. All the nixi tubes seem to be working, or at least all the zeros are working. Don't know anything more. You've seen just as much as I have now. We'll try and see if any of this is working. So he said addition works, so we'll start with that. Also notice we've got 3 decimal points and the thumb wheel is set to 3, so we'll try changing that first. I've got it now set to 6 functions. Now we did say that addition worked, so we'll try that first. So I'll set the decimal point to 0, hit clear, and we'll enter a 1. Good first sign. We're getting a 1 showing on the display, and we'll try adding 1 to that, and we're getting a 2. So first impressions are fairly good. It's looking like fundamentally it's working. We're getting the basic process in the state machine working. We're getting the display working. We'll see if all the display drivers work now. Okay, so we do have an issue in the higher order bits. And we are also getting proper operation of the decimal point selector. So that's 6. Try setting it to 3. And that's working. Now what's strange with this machine is you've only got 0, 6 or 3 decimal places that you can select. I'm surprised there isn't a 2. A lot of these machines were used in financial institutions, so you'd think that there would be an option for 2 decimal places, so it's kind of strange that that's not included. Okay, so we know there's at least one fault. We'll try seeing which of the keys work on the keyboard. He said that multiplication didn't work, so we'll try that next. So 1, so it can see the key. 1 times 5 is also not working. So things like the percent won't work because that requires the multiplication function and division. So we'll try division next. So 10. So again, it can see the key divided by 2, and it doesn't like that, so it's just looping round. So clearly the state machine's not working correctly. Most likely some of the counters aren't working the way they should. We'll try subtraction now, so we'll start with 9, and again it can see the key. Clearly this isn't right, there's something wrong with that already, but we'll try going ahead anyway. And it's kind of doing something. It's not just ignoring the key presses, it's just coming up with some fairly bizarre values. So it can just be something as simple as a connection on one of the boards, but it's quite interesting the way these work. So what I want to do now, because as I said, it's got a fairly unusual memory system, so I want to see if that's working correctly. And this is a good method to use before you open something up. Just go through, see what information you can get from the basic operation of the unit, and especially a machine that's discrete like this, it can tell you an awful lot about what the potential faults might be. So we'll try putting 1, 2, 3, and we'll put that into memory and see if that actually works. So if we clear this and then try and recall, so memory's working. That's a very good sign, especially because of the nature of the memory in this. It's quite important that that works. It is quite difficult repairing the memory on this, and as I say, we'll go into why that is as we go through this series. We'll now try the cancel keyboard key. So what that should do, if we enter a new value and we decide we want to change our mind, we can clear that and we should be able to recall the value we had previously, which we do. We know the percent key won't work because multiplication and division don't work, so that's not going to function. I don't know if accumulation will work. I suspect not, again because the multiplication doesn't work, so that's not going to do anything, which it doesn't. So it looks like we've got some basic operation of the machine, but all the keys seem to work. and this is what you can end up with. We've now got multiple digits on each of the nixi tubes lit up, so that's not necessarily a fault as such. There are some bugs in these units that can cause that. So it looks like we've got some basic operation. It's not completely dead, and the drivers for the display seem to mostly work. And let's try. Okay, so that's not working either. Okay, so it's not working as it should. There's obviously an issue with this, and it should be quite an interesting one to repair. Okay, so what we'll do now is we'll get this opened up, we'll have a look inside and try and figure out the best approach to take for repairing this. So these are easy to get the top cover off. There's just a couple of screws on the back, so we've got one here, one over here, and then there are a couple of clips at the front underneath. So I'll take the screws out, unclip the top cover, and we'll get this top cover out of the way, have a look inside. So that's the top cover removed. You see it's a very substantial build. It's very nicely made, very dirty in here, so it's going to take quite a bit of cleaning. And the boards don't look to be in terrible condition. I can't see any evidence that any work's been done on this previously. Almost certainly will have had something done, but doesn't look too bad. I can't see any kind of horrible hacks or anything. This also uses the old kind of phenolic type PCB material, and this itself can cause an issue. This can absorb moisture over time depending on where the unit's stored, and on a unit like this that uses high voltage to drive the displays, it can cause an issue. I suspect that's not the issue here, but what I'm going to do now is pop all the boards out of this, and we'll have a quick look at them, and then see what the best plan of attack is for this machine. Okay, I've removed the first board. This is actually the memory board, so these capacitors are what are used to store the actual bits of data, and as with any capacitor, the charge on them will bleed away if they're not recharged. So like all dynamic memory, there is a refresh system built into this unit that refreshes the data in the memory at regular intervals. So we'll perhaps look at that in a future video. And if ever you work on one of these, all the boards are numbered. 8 is the one at the rear, so it starts at 1 at the front and works its way. There are 8 boards of course, and the rear one is number 8. Some of these components have been kind of folded over in a bit of a strange way, and it looks like there has been some work carried out on this. And in particular, if we look on the back, there's a very obvious what looks like a repair down here. A lot of scraping and scratching on there, so I'm not quite sure what was going on there. Memory seems to work up to a point, so we'll perhaps come back and look at that another time. We've also got some scraping and scratching down here. Again, not quite sure what was going on there. No sign of the solder having been disturbed. Okay, so that's the first board out. Now these, I don't think these boards have been out for a very long time, and they sit in edge connectors down in the bottom of this rack. And if you're trying to get these out, they are really tight. And one thing I tend to use to remove these, I don't know if it's intentional by Toshiba when they designed this, but normally when these are assembled, you have these 2 arms sitting across the top of the boards, and to get the boards out you just remove 2 screws from either end, and then these will just kind of lift out. And these make extremely good extraction tools for these boards. I don't know if it's intentional, but what you can do is these kind of dogleg ends, not the right angle ends, but these ends, the ones that normally sit at the front, there's a notch at each side of the board, and if you put the tip of the dogleg into that recess in the board, you can lever these out, and they make extremely good removal tools. It makes getting the boards out extremely easy, and you don't do any damage to them, and then they just lift out. So I'm just going to remove all the boards. Again, it looks like there's something been going on with this. Can't really tell if it was part of the original assembly, but you can kind of see the type of assembly. This was done back in the 1960s, so this is actually quite advanced for that period. I can't see any disturbed solder joints on the back of this. It doesn't look like it's been disturbed for a very long time, so we'll get the next board out, again using the, I don't know if they're official or unofficial removal. Okay, again, it doesn't look too bad, needs a clean, but other than that I can't see any work that's been done to it. Okay, I'll work my way through. If I find any boards that show any signs of obvious damage, then I'll get back on camera, but other than that I'll just get the rest of the boards removed. So I've removed all the boards. I didn't see anything obvious with them. There's no sign of anything being burnt. Quite a few of the components are folded over and touching each other, which is not good, so I'll start going through the boards and tidying them up. They all need a good clean anyway. I've also taken out the power supply. Just move the camera across. So that's the power supply removed. It's odd how they went to all the time and trouble to tape up these connections and screw them to the case. Not sure why they just didn't cut them off, but I'm going to leave them where they are. I've obviously unplugged this, had a quick look at it. It doesn't look too bad, but I'll go through, do all the usual checks. No sign of anything having overheated. Can't see any evidence that anything is not where it should be. So there's no components missing as far as I can see. These two pots are for adjusting the plus or minus 10 volt supplies. So this uses plus or minus 10 volts and I think 180 volts for the nixi tubes, and you can adjust the two main rails. So we'll check those. I'll test all this independently as we go through the videos. I've also of course removed the keyboard, so that comes out as an assembly. You can see badly in need of a clean, it's absolutely filthy, but otherwise it doesn't look too bad. So again, no sign of any broken parts or any failed parts. So we'll get back to that. Chassis needs a really good clean, but is in reasonable condition. I still haven't decided what to do about whether I will refinish this or not. The mains cable definitely needs to be replaced. When you see cables like this that have twisted internally, it's possible that the internal insulation is starting to break down, so this needs replacing. It could short out and obviously could also represent quite a significant risk to life and limb. Getting this out is fairly easy. You just remove the 3 or 4 million screws that hold it to the base, the access from the underside and a few along the back, and then it just lifts out. I mentioned there were two catches that you pull forward to release the top cover, and that's what these are. These protrude through the base of the unit, and you can use these to release the top cover once you remove the screws at the back. So I'll get the supply out of the way and we'll have a quick look at the main chassis. So the main chassis is quite an interesting assembly. One thing I've noticed with this, it has been dropped I think at some point, although it might not be that evident. This side cheek is fairly badly bent, as is the other one. The whole thing is twisted, so I've got a feeling that this machine's been dropped and has sustained quite some damage, so I'll probably need to remove these side cheeks and straighten them out to get them to fit properly. It's not a huge issue, it's just another job that I'm going to do while I have this apart. If we look on the underside of this, so what we've got here, if we just turn it sideways, is we have the edge connectors that the main boards sit in. I'll clean all these contacts. Don't look too bad, some show a bit of corrosion on there, but nothing I would have thought serious enough to stop them making contact. But you can't always tell. Sometimes a simple dirty contact can cause all sorts of problems, and that might be the source of our issues. Just flip this around. And you can see that it uses a wire wrap system. And one thing I've noticed on this is there is a lot of corrosion on these pins, and I'm starting to think that this might well be where our issue lies. We've seen this sort of thing before. We saw something similar to this on the PDP machine that we looked at recently, and this can cause a lot of problems. It appears they did not use gold-plated pins on these connectors, so we might well have an issue with this. I can buzz these through and see if they're intact. It's just time consuming, but is the probably the place where we'll start in the fault finding for this. But the next step is to give everything a clean. I won't do that on camera, it's a very tedious process, it takes quite a long time. But I'll go away, get these cleaned, and in the next video we'll start working our way through the machine from the literally bottom up. So we'll start with this this rack, try to test it as best as we can, and the way I do this is just to test the connection between the wire wrap outer and the pin, but we'll come back to this in the next video. But this should make quite an interesting repair series. We've also got an issue with this, it's not working the way it should, and hopefully we'll be able to get this restored and fully functional. These are very interesting machines, and as I said, especially because they use a very early form of DRAM, it should make quite an interesting repair.